All right. Well, I would like to thank everybody for attending this webinar on the new TerraSource Demonstration and Development Center. My name is Brian Lanham. I'm the Director of Product Development for TerraSource Global. What we want to talk about today is listed here. We're going to go briefly through a little history on the four companies have kind of come together and what kind of testing we've done in the past. Talk a little bit about our new location in the Duncan, South Carolina area, and what we've done with that facility as it exists currently today, mostly bringing in the Jeffrey Rader lines of equipment. Then we're going to want to talk a little bit about our planned expansions that we're going to be doing in 2014. We'll discuss the classification abilities of our lab and what kind of test analysis we can perform. We'll talk again a little briefly on the materials that we can test. Talk about the new training center, which is also located adjacent to the lab, and then we'll have some time for questions. So let's go ahead and begin. Got a couple of charts here that show just a real brief synopsis of the four companies and how they've, when they were organized and kind of some of their general history. The Jeffrey facility, they first started their full-scale testing lab in Columbus, Ohio in the 1920s. That lab had Hammermills and roll crushers in the single, double, and triple roll configurations. Most of the work at that time was testing coal, and that facility in Columbus was in operation until about 1995. The Woodruff plant in South Carolina was built in the 1965, 62, somewhere in that time frame, and they built a full-scale lab in the early 70s. And they did extensive Hammermill testing in addition to vibrating feeders and wastewater testing. At that time, they were building a lot of wastewater equipment. Some of the parts of our existing 30 series Hammermill that we'll see shortly are from that original Columbus lab and are about 70 years old. Gunlock had several test centers over the last 50 years. Their earlier labs were standalone facilities. The current testing facility they have at Gunlock is actually located in the back of the manufacturing plant, and that's been around since about 2006. Most of the testing at Gunlock is centered around the different roll configurations that they've developed over the years and testing those on customer materials that are brought in. They've also done a lot of testing on the cage pactor design and using the differing speeds and rotations of that unit to meet customer performance requirements that they may have. Pennsylvania Crusher is also a company that's been around for a long time. They started with their lab in the 1940s. One of the lab units that they have in the Broomall office right now is a C330 Hammermill, and that was put in just shortly after World War II, and we're going to be very happy to have it join us as well here in Duncan next year. The Broomall lab was put into operation in about the 1960s and has done just about everything from random customer testings to full-scale runs where customers have brought in literally truckloads of material and gone ahead and the lab processed them and they were put back on trucks and taken back to facilities for additional testing that material. On the Raider side, the Raider side was the youngest. Our lab was set up in the 1960s in a small warehouse in Portland, Oregon, and they acquired some larger space in the 70s. Most of the testing at Raider has been around pneumatic pipeline conveying and chip thickness screening. The facility in Portland also did some interesting things like municipal solid waste and garbage, and we also had a line at that time of rotary dryer equipment, and we had 2 full-size units on that site that could process materials. The Raider side has also done a lot of testing at customer sites, and also done some full-scale testing, as I mentioned, at Pennsylvania Crusher. The Raider site's also done tests where really large amounts of material have been processed through the equipment and then hauled back to the customer sites to be further processed and refined. The Raider site also did a lot of on-site audits of chip thickness screening system, where we would actually measure, get samples and measure performance on a number of different parts of the system at the same time, and then use that to determine the overall system efficiency. And I guess the point that I wanted to make here is, going through this short little history, is that these 4 companies all have had really extensive training capabilities over the years. It's not the whole idea of us having a testing facility and having a place where we can bring materials in from customers, as well as doing our own research and development work. This is all something that we've been doing for many, many years, and when the TerraSource brand was put together here recently, it was one of the first thoughts that people had, was to let's go ahead and get all of our equipment in one location at one site to be able to show that to customers. Customers can bring in their material and they can test it on all of the equipment instead of having to go to each one of the different locations to get a full idea of what can be done. So let's go ahead and move on. This is a picture of our current location in Duncan. It's brand new. We just moved into it about a year ago. The facility actually has been here a little while, but we're here. We just moved here a year ago. It's located between Greenville, South Carolina, and Spartanburg, South Carolina. It's near the Greenville-Spartanburg Airport. It's only about 15 minutes away, and we're just minutes off of Interstate 85. So we're in a great location. We're in a business park that has a lot of suppliers in it for the BMW auto plant that's nearby in Greer, where they make all the luxury SUVs. This is the way the facility looked when we first moved in. This office space included a fairly large space for both a warehouse and a lab. So we're all integrated, all in the same building. The office space, the warehouse, and the lab are all right together, and that makes it extremely convenient for us to be able to get things done quickly, and you can run out real fast and take a look at what's going on. We've got about 9,000 square feet of floor space, nice smooth concrete floor to be able to lay material down on, 21-foot ceilings and skylights, and we just added high-efficiency lighting into this lab as well. This is the way it looks now as of September 2013. The picture on the left is the Jeffrey Rader Hammermill sitting on top of a discharge box, and we're going to talk more about how all this equipment is kind of arranged later. The light blue colored piping is an air system that allows us to be able to pull a slight vacuum in that discharge chamber. Also visible in the lower right of the left picture, you can also see a Jeffrey Rader scalping screen that can be fed off of a transfer conveyor. Here's another view kind of looking at the other end of the facility. Here we can see on the far right the Jeffrey Rader vibrating feeder with its hopper, and it feeds a rather long conveyor. That's our main C1 conveyor. You can also see some of the air piping in the discharge box with the Hammermill in the background, and we've got lots of storage racks arranged all over the place to hold all of our spare parts for testing. We have a very, very wide array of different test setups that we can put into our equipment, and we've got that all arranged on some racking. Here's a few more pictures, just showing the arrangement from some different views. The picture on the lower left shows the C1 conveyor coming up into a transfer chute flock gate arrangement, which allows us to be able to go between the Hammermill and another device or another piece of equipment that we can have on the floor. Currently, the scalping screen is shown down below in that particular position. On the right side, you can kind of see the other side of that same room, and that down that aisleway is where a lot of our classification equipment is. And we'll be talking more about that as we continue on here. Want to take just a real quick, brief tour through the equipment itself, and just show you a little bit more in detail what we got. The first thing at the end of that C1 conveyor is the HP100 electromagnetic vibrating feeder. It's got its own little in-feed hopper with a metering gate on it, and we put that on a roll-around base so we can not only feed the C1 main conveyor, but we can also move it around to different parts of the shop and or the lab, and we can feed it into a barrel, or we could feed it into the bucket of our skid steer. There's lots of different arrangements and ways that we can use that particular piece of equipment. The C1 belt conveyor, 30-inch wide, 60 feet long. It's driven with a VFD so that we can adjust the belt speed of that unit. And through that, we can get different in-feed rates into the Hammermill or whatever other device that we're going to go ahead and feed. We've got an Excel spreadsheet program that allows us to quickly calculate what the rate is that we're going to run based on the number of feet that we've laid material out over the belt and the speed of that belt. And the program will give us an idea how long each test will run. Normally, we like to try to run tests that are at least 10 seconds long. That kind of allows us to have our amperage levels average out and level out a little bit on the, especially when we're doing the Hammermill test. You can see in the picture in the lower center, that's a test we did recently with lignite coal, fairly large coal lumps. The test on the lower right is a recent test done on wood bark. Mentioned earlier about the transfer chute work and the C2 conveyor. That's a little bit better picture of that. You can see how it can either be fed to that transfer conveyor, or it can just go ahead and go on down into the Hammermill. This C2 conveyor was something we added when we moved to Duncan. The original facility in Woodruff did not have that particular addition. But with that exception, just about everything else that we've seen here was actually installed in the Woodruff facility a little less than 6 months ago. And we just recently moved it over. Here's the Jeffrey Rader Hammermill, and this is a real versatile unit for us. We have got lots of parts for this thing where we can configure it to be just about any current production model of equipment that we make. It can become a WB bark and wood hammer mill. It can be an AB General Materials hammer mill. It can be a flex tooth crusher for coal and other easily friable materials. It can be a chip sizer for wood and wood chip sizing. And it can also be a mini mill variant. We use those for a lot of sample work. In addition to these main categories, we have lots of parts, like I said, to be able to even do other things. It's a pretty long list. So it's a very versatile piece of equipment. We've had this hammer mill for years, and it's just a real good little workhorse. This unit is hooked to a 125 horsepower motor, which is also connected to a VFD drive. So we can vary the speed of this unit by the VFD. We also have a full set of shivs that goes with this hammer mill, and the idea there is that for some of the testing that we would do, we want to be able to have the full torque available to this unit at the slower speeds, which the VFD will not do. So by adjusting the shivs, we can get the full torque at the lower speed and be able to do those lower speed tests effectively. This little hammer mill, we can actually vary the speed anywhere pretty much between 300 and 2,400 RPM. The hammer mill sits on top of what we call a discharge box, and it's basically a static settling chamber. The idea here is that in many of the lab installations that we've seen and had in the past, we would have a tendency to lose a lot of finer material because there is a little bit of an airflow that's going through the hammer mill during operation. So the idea was to enclose a chamber below the hammer mill that would allow us to make sure that everything that is tested through the unit actually stays in this discharge box. The discharge box also forms the main structure for the hammer mill to support it. There are big doors at either end that we can roll a self-dumping hopper in and out of the unit. That catches the majority of the material. The material that falls outside that can be easily swept up from the concrete floor and added to any sample that we run through the unit. And that sample then be thoroughly mixed and a representative sample taken out of it for classification. The air piping that we start to see in this view in the lighter blue color allows us to be able to pull a little bit of a negative vacuum out of that discharge box, with the idea of that being that in some configurations of the hammer mill, we may want to actually be pulling a little air through the grates to help material flow. And that's especially important when we're doing testing with really small size hole perforations in the hammer mill. It also can help us just generally keep the lab a little bit cleaner of an environment. We're pulling a little bit of air through the in-feed of the hammer mill as well, and reducing the amount of material that might just get kicked back up in the in-feed chute area. So we found that this kind of an arrangement seems to be very, very effective at being able to kind of control and keep our housekeeping of our lab to a minimum. And here's a couple of views that you can see where the air piping is a little bit more evident. And you can see on the photo on the right the air handling fan that we have, the vacuum piping coming in from the top right and going down into the fan. We have another space for another pipe that we're going to see here in a minute that will be coming from the other new equipment that we're going to install in 2014. Mentioned earlier, we've got a Jeffrey Rader scalping screen that's also available for testing. We use this for both customer tests and for development testing on the unit. We designed it specially so that we can adjust shaft centers and disc spacing easily on that particular unit. To power everything, we have a fully industrial style electrical system with 480 volt three-phase power. We actually installed a new transformer in the building when we got here to make sure that we would have plenty of power to be able to run up to 200 horsepower motors, and we could probably even run over that if we had to. And again, like I mentioned, we're using VFDs in this case for both the Hammermill and for the C1 conveyor, and that allows us to be able to reconfigure and change between testing very quickly. We also have a rather ancient computer that runs our data acquisition system, and what we do is for every test on the Hammermill, we currently are recording the amperage that's consumed during that test, and we can put that in the file with the test information and be able to refer back to that at any time. We started doing this about I guess it was about 10 years ago on the Rader side, and we found that it's just really handy to have that data acquisition data available, especially when we're handling the new materials that we haven't maybe tested on before, and that helps our sales and applications department be able to see what's really going on. The image on the right kind of shows a test report where everything has kind of been cataloged out, and you can see the way the amperage was run during that particular test. So that's pretty much what we've got currently here at the DDC. Now I want to show you quickly what we're planning for 2014. We are really excited about the new additions that we're going to get from the Gunlock and Pennsylvania crusher side of the business. What we're going to see here in the next few slides, this is a fully funded, approved project that we are just getting started on now and hope to have installed in early 2014. The first piece of equipment that we will have available is a Gunlock roll crusher. The unit that we've got currently at our facility in Belleville, Illinois, is a very old double-stage crusher. It's served us very well over all the years, but we're thinking it's probably time to go ahead and retire it. So we're going to actually build a brand new single-stage crusher, a 2013 unit for the lab. It will have a 25 horsepower motor attached to it, and we'll have the standard nitro oil system attached to it, so that that will provide automatic relief for tramp and rock that may get in the system. The nitrile systems are really a very clever way to have a low-cost relief system to prevent damage to the crusher rolls. We're fortunate that the unit that we're going to build is, and will look just like the picture here to the left, it is going to use the same profiled rolls that we already have in stock in Belleville. So when the new unit comes in, we'll already have a very large inventory of different profiles and shapes that we can run through the crusher to test for customer demonstrations and also other research work. On the right, you can see a solid model image of kind of the way that's going to end up looking with the motor on top of another discharge box similar to the one that I previously described. And we feel that we're going to have the same advantages with housekeeping and controlled airflow through the equipment with this arrangement as we do on the equipment we've presently got installed. We're also going to have a gun lock roll crusher, which just so happens to be the same size unit that we were just talking about with the roll crusher. The difference with this unit is it's going to be driven by two 25 horsepower motors, and it is going to allow us to run those rolls at different speeds. And so we actually get more of a grinding action with this particular piece of equipment than we would with the crusher, which is running both rolls at exactly the same speed with an incoming nip. The material passes without actually having a grinding action happening to it. This unit will have an adjustable gap between the rolls, just like the crusher does, but it will be a what we call a fixed gap. It won't actually be adjustable during operation, and it will not have the nitrile system to provide tramp relief. So when we're feeding this unit, we just have to make very certain that we don't have any tramp or metal or any other non-compressibles in the flow. And for this unit, we will have brand new rolls built with some smooth and finely profiled rolls that will allow us to do that testing on the grinding and the smaller fraction sizes that this unit is capable of. We're also going to have a gun block cage factor. The unit that's at Belleville is a rather large unit. It's actually what is designated as a Model 50B. It's a little too large for our facility here in Duncan. So we found a unit that we had previously sold to another customer, and this unit is now back at the Belleville shop. It was actually just test run not that long ago, and it's being just cleaned up a little bit, and we're going to add the cage jack to the unit, and it will come here with the roll crushers when those are completed. The gun lock units use a flat blade cage design that is very efficient at using these impact flat plate surfaces to reduce the material. It just so happens that Pennsylvania Crusher also makes a cage mill design, which is very, very similar to the gun lock unit. And we're going to go ahead and invest and make an additional set of cages that will use a round pin design that the Pennsylvania Crusher pioneered. And so we'll basically have both of these different style cages available for testing on the unit when it's here in Duncan. From Pennsylvania Crusher, this is the C330 Hammermill Impactor that I was talking about earlier. This is the unit that was built just shortly after World War II. It's been through a few different configurations at PCC, but this is the way it currently looks on the right, and in the image on the left you can see the way it's going to be put into our system. This particular unit uses impact in the upper section, and there is the possibility to use discharge grates in this particular unit, or the unit can be used without discharge grates. It's simply a matter of throwing a lever, and you can test it both ways. So we'll be able to have that installed. The rotor in this particular unit is reversible, so you feed the material in and you can run it one direction or the other, and that will, in normal applications, that equalizes the wear during operation. And the material size is dependent on the RPM and the discharge grate size if it is used. These particular units are very effective at, it was originally designed for coal, but it works very well for other easily friable materials. Next we have the Pennsylvania Crusher CA Impactor. These impactors are largely used for secondary and tertiary crushing, and occasionally for primary work. Used a lot in cement, rock, gypsum, fertilizers, chemicals, lime, agricultural limestone. These units are capable of a fairly high reduction ratio, up to 35:1, and they're a fairly high capacity unit. Our unit will be it's designated as a CA impactor, and it will have I think it's got a 50 horsepower motor attached to it. This unit doesn't have any discharge screens or cages with it. Next we will have the Pennsylvania Crusher Granulator. This particular unit is going to be a GT 26x20 with a 25 horsepower motor attached. These units use a ring-style hammer that kind of use a combination of a rolling and a crushing, a rolling or an impact type action. Product size is determined by the screen grate openings, the speed, and changing the clearance between the hammers and the grate. These units are used a lot on coal and gypsum, salt, and other somewhat moderately hard materials, and are also capable of fairly high reduction ratios. We'll have a small Pennsylvania Crusher posimetric feeder that will be also available in the lab. These units are a very unique feeding device that allow you to feed materials into things like cage packers and hammer mills at a very controlled rate, and they have extremely low wear due to the fact they only have one moving part. It's a very, very simple construction. It works very, very well, virtually maintenance-free. And we'll have this unit here in the lab for customer demonstration purposes mostly. We also are getting another antique from Pennsylvania Crusher. They've got a very, very old vibrating screen. This was a product line they used to sell a long time ago. We currently don't offer it for sale anymore. It's pretty old. It's even a little bit on the rickety side, but it is a unit that's available for us to be able to separate larger samples into smaller ones. So it's kind of one-of-a-kind antique, and we're going to go ahead and bring it here. We think that we will use it, and we've got a full set of screens for the unit, so we can use it to pre-sort material before we run it through the Hammermills and the impactors and even the crushers. We'll also be getting 2 metering conveyors from both Gunlock and from Pennsylvania Crusher. The unit on the left, in the lower left, is the one from Gunlock. The one on the lower right is the one from Pennsylvania Crusher. And these units are both connected to VFDs and have small hoppers with metering gates above them. And this is going to be what we're going to primarily use to feed the Gunlock and Pennsylvania Crusher equipment lines. You can see in the upper left view the solid model image of the Gunlock feeder the Gunlock metering conveyor feeding into the Pennsylvania Crusher granulator. So kind of in synopsis for our planned 2014 expansion, we're going to have the posimetric feeder. We're going to have the C330 Hammermill impactor. Next is the CA impactor, the GT granulator, the 40B Gunlock cage pactor, which will also have the Pennsylvania Crusher cages available on it. We'll have the 2030 Gunlock roll crusher and the 2030 Gunlock roll grinder. And as you can see, all of this is going to be mounted on top of a very long discharge box, settling chamber, same basic arrangement as what we already previously went through. And you can see the air piping that will also be used to pull a slight negative pressure out of that chamber. And that'll all be attached to the existing fan and system that we already have. Next, we're going to kind of quickly move through this. Wanted to just show very quickly some of the classification abilities that we have at the DDC. We have a BM&M classifier, which is a 2-axis horizontal shaker. And you can see we've got a variety of round hole trays for that particular unit. We use this for most all materials. It's kind of a general purpose workhorse here. In the picture in the front, in the lower portion of the picture, you can see one of the trays with kind of a small hole perforation in it. We also have a chip class classifier, and this is a 1-axis horizontal shaker, so it kind of shakes back and forth, where the other one kind of has a horizontal rotary motion. This is used a lot for wood chips, but we also use it for many other types of materials too. And you can see on the left the different perforated plate round hole sizes we have. We also have square holes available for that unit, and we have a few round bar slots, which quite frankly don't work really very well, and we don't use them very often. From both Gunlock and Pennsylvania Crusher, we'll also be having each one of these locations has a Gilson Testmaster, which is another 1-axis horizontal type shaker. And these use wire mesh trays to sift the material through them. Some of the trays are inch size square holes, and then as you get into the lower sizes, the finer sizes, we have trays in US mesh, which are also convertible over to Tyler screens of sizes if we need. And we also are going to have, from every location, we're going to have 3 of these, the Gilson Rototap style horizontal shaker, which also has a vertical tapping motion to help keep the screens clear. We use these things for any time when we have really fine materials that we're trying to get classifications on. And you can see on the lower part of the screen there one of the trays sitting out in front of the unit. There's another tray sitting on the table that's a little bit larger in size. And we have a pretty wide array of mesh sizes that are available for these units. We also have a Jeffrey Rader CC2000 thickness classifier. This unit was developed back in the 1980s for classifying wood chips to thickness instead of size. It's a highly effective unit. It really is primarily only used on wood chips, but we could end up using it on some other materials depending on how that all goes. It's a computer-driven piece of equipment. It's got automatic scales below it, and the slots in the drum can be set up to be just about anything between 2 millimeter and 24 millimeter when you're doing your classification setup. We're also going to be getting some additional equipment from Pennsylvania Crusher and Gunlock. In the lower left, you can see a really large sample splitter that can be used to split apart large volumes of material. A smaller sample splitter is to the right of that. And then we'll have a full array of digital scales, floor scales, forklifts, skid steers, everything you need to be able to handle large volumes of material and be able to split them, get representative samples out of them so that you can classify them in these classifiers that we've just looked at. Once we classify all this material, then we need to analyze it. And we can analyze by a number of different ways depending on what the customer's requirements or our own requirements are. The most commonly used analysis that we do is a retained on tray percentage, where basically we just take the weight of each one of those classified trays and we will gather the sample off of the top of that tray. We'll go ahead and weigh it and put that into a table and then turn it into a percentage. Another way to look at that same data then would be to get a cumulative above tray percentage or a cumulative through tray percentage on the same data. The image in the center, which may be a little small, a little hard to read, but it shows a recent classification we did where all three of those data percentages are combined into one graph. And above the chart is the data that was gathered and the percentages that resulted from that data. To the left, we can see an example of a comparison report where we maybe have made, in this case, in the lower left, the black line represents the in-feed material, and the blue, green, and red lines represent the actual testing that was done, in this particular case, on different roll gap settings on a Gunlock roll crusher. And off to the right, you can see an example of an averaging report where we might take a number of samples and they might be widely skewed, and we can go in and we can create an average from that. So there's a wide variety of ways that the samples can be reviewed and analyzed, and all of that gets put into a test report that we would generate at the end of the customer test. Other testing that we may also be requested to do are things like a bulk density check we do that a lot, where we're making sure that we know approximately what our pounds per cubic foot or kilograms per cubic meter are. We do some moisture content testing, both on a bone-dry basis and also on a wet basis. We only do that on really small samples. We don't have a very large drying oven. We do have a company in the area that can do drying for us of larger samples if needed. We have done percentage of bark in a wood sample on a weight basis, and that's just basically a painstaking process of going through and picking out all the pieces of bark out of a pile of wood and then weighing both of them and getting a percentage of it. And we also have done percentage of over-length material in the sample. If a customer is interested in, especially in the wood and bark areas, if you've got a requirement that you don't want material over a certain length, then you can go ahead and we can go through and do a quick check, pull out all the material that's over a certain length and give you a percentage based on that. And then also there's customer-specific testing, and we do this, just when necessary. Right now we're in our DDC, we're setting up for a test that we'll do just after Thanksgiving here in the U.S., where a customer is going to pay to have us run material in a closed loop and run it through a rotary airlock Jeffrey Rader feeder for testing on a material that we've never played around with before. So we have some extra conveyors in our boneyard, and we've set those up and with some shooting and some structurals to support everything. We're going to just go ahead and do a test like that. We've done a lot of testing out in the field, as I had mentioned before. About a year and a half ago, we did a test out at a customer site where we set up a small pneumatic system and tested wood pellet conveying in a pneumatic system. So when it gets to that kind of a thing, we can do just about anything, and that's where you have to talk to the customers. We have to really understand for sure what the requirement is that the customer wants, what we're trying to achieve, and make sure that what we test and what we do is going to be relevant for what they need. In just about all cases, a customer test will generate a DDC lab report, which will outline the testing that's been done and the results that are generated. And in that report, we'll have the contact information, we'll have the test objectives, the equipment that's been used, the procedure, the test results, a test summary, any recommendations that we may have, and then all the test data, graphs, charts, everything else that would be relevant for the customer to fully understand what it is that we have done. Here's a quick list of some of the different materials that we've tested just this year. Even with our lab partially down here in South Carolina, we've run quite a few tests on different things. Some of these tests have also been run at Gunlock and Pennsylvania Crusher. A more complete list of all the different testing that we may have done over the years would be in these slides, which I'm going through very quickly. I know that you're not able to read these directly, all of them at least, but the point being is that we have tested on lots of different products over the years, and so again, testing is no stranger to us. We anticipate and have a lot of fun whenever we get a chance to test new materials. There are some materials that we don't want to test on. We've pretty much given up testing anything that's hazardous, toxic, or a serious health hazard. In that short list that I ran through very quickly, you might have seen some interesting things in there that probably would fall in these categories, but we don't test on those anymore. Material safety data sheets, or safety data sheets as they're now starting to be known as, they may be requested if a test is, if we're suspicious that we may have some safety issues. Certainly things that are explosive or extremely flammable, we also kind of tend to refrain against as well. We had a question that came in earlier before the actual presentation about if we can control moisture and temperature during a test. The short answer is that we really don't have any way to do that here. We will try to leave material in its packaging until the last minute if it has a tendency to, for instance, absorb water or be sensitive to heat or cold. We have done testing on things like frozen coal, where we'll keep it in a freezer right up until the moment that we put it on the belt and run it through the machinery. We can also try to gather it up as quickly as possible and reseal those materials in pails or buckets. But it's very difficult for us to really be able to maintain a temperature or humidity controlled environment where we are. Here in South Carolina, it can get very cold like it did last night, or it can get very hot like it does in the summer, and we can also have wide swings in humidity. So that's just something that we have to kind of accept, and we try to do our best to keep materials in their original condition as long as we possibly can. When material comes into the lab, we don't unseal them until the last minute anyway. We also run a considerable number of materials through our equipment here in the lab, and we just need to make sure everybody's aware that there is always a little bit of a possibility of cross-contamination. It's most evident when we run something like coal that's black and then we run something white like a salt. You'll see, little specks of the previous test in there. We do everything we can to try to clean out everything as best we can, but that's something that we just have to accept, that we can't be 100% on that. And also any test materials and photos and other data that we collect during the testing process are our property. Very important that when you send materials into us that they are representative of what the material is that we're actually going to be using when we, if we were to offer a piece of equipment for a particular application. Sending in material that is kind of the same or maybe not even the same doesn't really help us when it comes time to actually do the application work for the equipment. So it's always important to try to send us materials for testing that are truly representative of what you want to do in the future. To set up a trial at the DDC, we have a lab test request form. Part of this form would be filled out by the customer, and some of it would be done by us. Once you contacted us, we will send you a return material authorization, and that's requested to be shipped back with the material. So once it hits our loading dock back here, we know what it is and what test it's for, and we can kind of track it as it goes through our facility. The lab test request form, when it's completed, that's when we will schedule the test. So the material has to arrive and the test request form has to be completed. Then we can schedule it, and the testing usually only takes 2 or 3 weeks. Usually it's even less than that. It just depends. Sometimes we're backlogged, sometimes we're not. most all of our testing is done on a first-come, first-served basis. So as testing materials come in, we go ahead and schedule the test and put everybody in queue. Adjacent to our test lab, we also have completed recently our new training center. And this is just a really nice facility to be able to have for larger group meetings. We can, customers that come in to witness testing can spread out in this area. There's also a couple of private offices with phone, internet connections. So it's kind of like you're home away from home when you're here. And it's also out of our normal office workflow. So it's a very private area. Nobody's going to bother you over there. It even has its own private entrance. But yet it's immediately adjacent to the testing center. And it has the capabilities for video conferencing and PowerPoint presentations and all of that. So that's available as well. So I want to thank everybody for attending our little virtual lab DDC lab tour. I did have one question that came in, or a couple of questions that came in from Steve. He was asking if I could show examples of feeding and crushing performance relationships to horsepower, flow capacity, and/or size, consistency out with respect to variations of moisture, crusher component wear, size, consistency in, and RPM. And wow, that's a lot of things. Well, we typically, when we do testing, we only change one or two variables at a time. But that would be kind of an example of the kind of thing that we would probably want to sit down with a customer and just ask, okay, well, what is it that's important for you to be able to see in this test result? And we would work out which of the variables were important to be maintaining during the test and which variables would be changed and what would be the most important ones to look at. It would be a pretty to have a lot of those done all at once. Well, if nobody else does have any other questions, we'll go ahead and close up here. If you do think of anything, you can see my contact information on the screen. So again, I thank you all for your time today, and hope you have a good day.